Cool. Hi everyone, I'm Humad. I work at Project Race with Jeremy. We're going to talk about ARC, automatic reference counting, which is what Swift uses to manage your memory. So ARC stands for automatic reference counting. It's a way for Swift to track and manage your app's memory usage. But before I go into that, I want to go back a little bit, talk about how we used to manage memory back in the old days of C in 1972, and where we are now and how that compares. So if we write a computer program, it obviously uses a bunch of memory, right? And then when we create classes or instances of classes, those also use up memory in your system. And when we would write C, we would have to manage memory ourselves. So we would call stuff like malloc and free. So malloc would give you a chunk of memory, and then free would free up that memory for you. And that's how we would have to do it for all our programs. So an example of that is right here. So where you have your int main, it's your main function. You ask for a chunk of memory and you get a buffer in return, and then you can serve whatever you want. Once you're done with it, you free it, right? So pretty basic, pretty straightforward. And it's really cool because you get to work with very low level stuff. And for people who are into that stuff, that's really nice. But this, and your program's also a lot faster because as soon as you're done with memory, you're just freeing it up, right? There's no other processes that are running. You're just doing all this yourself. But this is also really problematic because there's so much memory management that you have to do in large programs. So if you create like a large project and you have different classes and you're like allocating memory and deallocating, there's just so much overhead that you have to deal with. And it's also likely that at some point you'll just forget to free memory in a certain function, and that can cause to issues such as memory leaks. So if you've ever dealt with memory leaks, you know that they're really annoying and really hard to trace. What they mean is that you're basically just losing memory because you're forgetting to free it. So imagine that you have a function that's handling a GET request that you're getting from somewhere, and in that function you're creating a new class that does a whole bunch of stuff. And then let's say that you forget to free it at the end of that function, and you're getting like hundreds of GET requests every day. You're just getting all that memory, you're just using up all that memory and not freeing it. And if you just keep calling malloc and never freeing any memory, your system's going to run out of memory and just like die. And we obviously don't want that to happen. Also, 1972 was when C was first invented, just as a little tidbit. So you'll also hear a lot of people saying stuff like, well, I mean, we are smart developers and, we will just always remember to free memory. And plus you have so many tools these days that like help you figure out where you have memory leaks. And it's really easy to say that, but when you have like thousands of lines of code, it's hard to actually like implement all these things. And so then you end up having problems like these where these large web services crash because someone thought that, hey, I'm just gonna like remember to free it, but then they don't actually do it. This happened 6 years ago, but it's still relevant. So then what's the solution for that, right? Like what if you don't want to deal with all these issues? Well, then you have garbage collectors. For those of you who haven't, also who here has used C? Who here has built a large project with C? No.
Plus.
Just C. No one? Okay, good. So you haven't seen hell. That's good. So yeah, like a lot of us here have probably used Java because UMass teaches Java at like an entry level, and that's one of the reasons why they do it. Like it's not the only reason, but it's one of them. And back in like the 80s, you would still see C being taught at in an intro course. But they don't do that anymore because it just adds that extra bunch of logic that students have to deal with. When in reality, they just want to learn how to build like a simple application. So like modern languages like Java have these built-in garbage collectors, and what they do is they just free up memory automatically so that you don't have to deal with it. And you can just focus on the logic of your program. And so there are different types of garbage collectors. The really obvious algorithms, like if I asked you guys, like if you have a program and you want to write a garbage collector for it, how you do it, the like simple response would be just wait for the memory to be like filled up and then just run a script that will delete all the objects that aren't being used, right? But that's a very naive way of doing it. Java has a really nice garbage collector, which has like a 3-step algorithm. The first one, so it has like 3 different stages. So the first one is mark. but not Mark Zuckerberg, just Mark. What it does is it goes through your heap memory where you have all your classes that are being stored, and it checks if those instances of objects that you've created, are they still reachable by some part of your program. If they're not reachable, it marks them. And then it has a second step called sweep, where it goes through your heap again, and it looks at the things that it has marked and just removes them. The last step is a little complicated and also like really interesting, and I'd want to go more into it, but since this is more about Swift and Arc, I'm going to skip that. It tries to like compact your memory so that you don't have these chunks of memory just like lying around, because then it's hard to like put in new instances. So yeah, question.
Is there any reason why Mark and Sweep are separate things, and you just don't?
Oh, that's a good question. Yeah, so this is like a very broad overview of what happens. In reality, what Java does is it creates different memory spaces. And once it has marked things, those are in one space. And like when it sweeps them, it needs to move them to a different place as well. But it can't do that while it's marking it. Yeah, it's a longer algorithm. I'm just giving you like a very basic rundown of this. But yeah, so what's good about this? You don't have to worry about malloc and free. You don't have to worry about like managing memory at all, which is just super convenient. And you can just focus on the logic of the program. And it reduces the chances that you'll ever run into like memory leaks. You still can. There's different ways, but I mean, it's less likely. But we have some more issues now. The first one is your program will slow down a little bit. So it's hard to say like for how long it'll slow down. But these days, we have like such strong hardware that the slowdowns aren't that significant. But imagine you're using or you're playing a game or something, and every 30 seconds it just lags for just a little bit, just enough for you to notice, right? It just gets annoying, especially if it's an online game or something. And so we want that to not happen at all. And same with like UI stuff. If you have lots of animations running, you don't want them to slow down every now and then. And we also don't have a lot of control over when the garbage collector runs. We can predict it, but not with 100% accuracy. There's different algorithms that do it in different ways. Some of them wait for a certain chunk of your heap memory to be filled before it runs it. Others have like a time limit where every like X seconds it'll run it. Really depends, and there's different types of like different like compiler optimizations that you can do as well. So I said that like malloc and free isn't the best thing, and then garbage collectors have their issues. So what's like a third option for us? And we have Arc now. Arc is something that Swift uses to manage memory. Other languages also use it. And the way this works is we talked about this like a little bit when we were talking about classes with Michael. Was every time you create an instance, you create like a reference to that, right? And you can have multiple different variables that are pointing towards the same instance of a class. And what Arc does is it counts those references that you have. And when it notices that that some instance has 0 references now, it just gets rid of it. And so it's automatic. It happens, and it happens like really fast because as soon as it sees like no references, it just removes it. So all that is good, but then there are some complexities to it, and we'll get to that in a second. So I'm gonna start writing some code so we can see how this works real time. That's far. Can I zoom in?
Probably. I'm not sure. I think it's scrolling slowly.
I can?
Yeah.
Oh, it is zooming in? Oh.
Yeah.
Okay. Okay. So let's do something really basic. Let's create a class called language. Let's give it a name, which is a string. And let's have an initializer, which takes name, string, and all it does is it sets its name. And then I'm just going to print that this has been initialized. And then we're also going to have a dinit. And a dinit is like finalize in Java. So when something is about to be garbage collected, it just runs finalize, or in this case, dinit, just so it doesn't run into any other issues later on. And so here I'm just going to say let's just save time. And then let's say we have 3 different references. Okay, is this making sense so far? Okay, so let me create instances of classes now. we have Swift. Let's create Java, and then let's just say we have C. So if I run this right now, where's the terminal in here? Can you save it on your desktop?
Yeah, sure.
So this will compile it and run it. So it says Swift has been initialized, Java has been initialized, and C has been initialized. So that's exactly what we want.
That was all live, guys. I think we should give him a round of applause for that one.
Okay, so here's what we want to do now. We want to see how these references are working. So right now, Swift has a reference to it, Java has a reference to it, and C has a reference to it. So Arc is currently counting the references as one. Let's say that I want to point to Swift from reference 2 and 3 as well. So I can just do reference 2 equals reference 1, reference 3 equals reference 1. And what you should see now is you'll see Java and C being deinitialized. Which is, again, pretty standard. Like, you see that, Arc has noticed that these things don't have references to them anymore, so they just get rid of it. And now if I set 2 and 3 to null, we will, you probably already guessed, but Swift will still not be deinitialized because it still has one reference to it, right? And so then finally, if I get rid of that, then we'll see that Swift is going to be deinitialized. All right, is that making sense? Okay, so that's pretty basic. It's all like happening really fast, and yeah. But then we run into things called retain cycles, which again we talked about a little bit, but that's where things get a little tricky. So let me think of a cool example that we can do. Let's get rid of these. In fact, to make it more readable, let's say we have language, and I'm going to create a person class. I'm going to call this inventor. This is going to be a person. This is going to be the inventor of the language. And it's also going to be optional. So then let's say we have class inventor. Let's give this a name. And let's also give it the language that they invented. So it's just that. We have our init here and our dnet here. Also note that the dnet doesn't have any of these braces because it doesn't accept any parameters. Okay. So we have that, and I want my language to have an inventor here. So person, optional. Cool. So we create the language, we create the inventor. Let's say my language is going to be, does anyone know who invented Swift?
Chris Latner.
Okay, I didn't know that, so it's good to know. Person, how do you spell his name?
Chris, like C-H, yeah, and then I think 2 T's, probably 2 T's, yeah.
Okay,
Class name be person.
Yeah.
I'm sorry?
Shouldn't it be
The
in
class name?
Oh, yeah, you're right. What did I call it here? I call it person. Yeah, let's call this person. It's a good catch.
Yeah, that works.
Cool. And then let's say the inventor dot language. That okay. That's correct syntax, right? Yeah. No,
I don't think you need the.
it is optional.
But when you're assigning it, you don't.
Okay.
End up needing it. Yeah.
In person. Sorry. What am I? Inventor dot language and then language dot inventor. Okay. So now we have this, right? Let's see what happens if I run this right now. Oh no. And save it. Value operator type should be unwrapped to refer to member. Yeah, so I think I do need to unwrap that.
But use it on the right side of the equal sign. So language on the right side of the equal sign. Yeah, should have that.
Oh, interesting.
Maybe not.
Nope. Report execution contains null. So it wants. So we have an inventor of type person.
Inventor question mark language.
What do you think?
Wait, what?
It wants you to do option chaining, right?
Because the inventor is the inventor itself is optional, so you gotta put a question mark after
that. Question mark.
Yeah. So basically, just check.
I mean, I could just force unwrap it.
Only then will it access it. Yeah.
Cool. All right, cool. So we have these things initialized. Yeah. And then if I set them both to null, this would have been much better if you guys hadn't used Swift, because you'd be like, whoa, why is that not happening? But since you've already used Swift, you know that it's not going to work. And they're just initialized but not deinitialized because we have a retain cycle. Although these things are no longer pointing to these instances, the instances are pointing to each other. And so that's the problem, because Arc says that these instances will have one reference, and it can't get rid of those references because it's just a cycle. So how do we get rid of this? We talked about the unowned variable, the unowned keyword, but I want to talk about the weak keyword. So if I say something like, this reference is a weak reference, Arc doesn't count this as an actual reference. Like, we still have that reference, but Arc doesn't count it anymore. And so then if I get rid of one, it gets rid of the other one as well. So save. And so we see that they have both been deinitialized. So this is nice because you get to have some form of control over memory, even if it's not the best type of control. How do I get back to the...
4 fingers to the right or left. Yeah.
Okay. So yeah, you have some good things about Arc, where it's faster than your traditional garbage collector, because everything's just being done in real time. And we have all these smartphones, which back in the day didn't have a lot of power, and so you needed something that was fast. Also, as a side note, I grew up I'm not that old, but when the first iPhone came out, I was still young, and I would hear people talking about how Android phones are better because they have better specs, which is true. They do have better specs, but the reason they have that is because they were using Java. Now they're using Kotlin, but they were using Java, and Java does do some things slower, like garbage collection, whereas you have stuff like Arc, which is faster, and so it doesn't need as much power as Android phones would. But yeah. But so we have all these advantages, but then we also have retain cycles, which are just sometimes really annoying to deal with. And if we go back to when I talked about malloc and free, it was like when you have a large project, you can sometimes forget to call malloc or free, or just free, and then that causes issues. And similarly here, you can forget to set something as weak, and then you would have issues again. So it has its good and bad things, but we mainly use it for Swift and iOS because it's faster, and you need faster stuff for UI applications. I wanted to run this animation, but it doesn't run. Oh no.
Oh no. Oh, sad.
Oh no. Okay, so these things get translated over. Let me see if I can find these, because it was really cool. Give me 1 second. Okay. Here's an animation that I found. Let's actually look at this one first. So the black area is free memory. The green stuff is memory that's been recently allocated. And if you see red dots, that's when the garbage collector kicks in and saves up some memory. So let's just wait for that to happen. So you see those red flashes? And then notice it's going to stop. Like that brief second where it stops, that's really annoying with Java's garbage collector. And this is like a mark sweep garbage collector, which Java sort of uses. And this is a reference counter garbage collector. Notice how the red dots just show up and they just do their work without stopping the whole application every now and then. And this is how Arc works. It's very real time. So that's what I had here, but this
Does it have to like collect or whatever the last step for Java's garbage collection was?
So
Does it have to bring the memory together?
So that's not what the animation was showing. There was another GIF that I didn't show, but that was basically the compacting part. But yeah, that's the third step. That one was just a mark sweep collector where it just like marks them and removes them. Java's like algorithm has a separate step for compacting as well.
No, but does Arc have to do that?
Oh, that's a good question. I want to say yes, but I'm not 100% sure. But it would make sense to do it because if you don't compact your memory, you can have these little chunks that are just going to be unused. But yeah, it's something that we should look into. So, where are my notes? Oh no, you weren't supposed to see that yet.
Maybe exit. They might be over there. They might be on the other screen.
Oh.
Oh no, I guess because you went into presenter view.
Yeah.
So present again. And then we can grab the notes. The 4-finger thing.
Okay. Yeah. So so we talked about these three different approaches: malloc-free, Java's garbage collector, and then Arc. So now you might be thinking, well, I know so much about Arc, and Arc is obviously the best thing ever. So then when you go to a party and you're like, I really want to impress this person, and you talk to them about Arc, it's likely, if it's a party in the CS building, you'll encounter someone who will be like, no, Java's garbage collector is so much better than Arc. And then you'll meet someone who will be like, malloc and free is the best thing ever, and you're not a real programmer unless you program in C. So you have all these like different approaches, and the reality is we don't really have the best solution. There's a best solution for certain, if we have like certain requirements, we want to maybe pick something that works best for that requirement. But there isn't like a general best algorithm that we can use. So yeah, we use Arc for UI and like all this stuff for phones. And then Java is great for if you have like a large application and you don't care about like if it stops every now and then, as long as it's doing things fast, you can use Java and like its garbage collector. So yeah, and then I couldn't find a relevant XKCD for garbage collection, but I did find one for like what the real programmer is, and I thought this was really cool. But yeah, so. So that's all I have for you guys today. I also just want to like end this by saying that I worked with Swift for 1.5 years now. Started out with like not knowing much, but that's okay because like this stuff a lot of this that you saw in the presentation, I just learned like a few days ago, and I did that by like reading blog posts. Like you have tons of YouTube tutorials. All this stuff is like available online, and you can like read it and learn it. And yeah, if you guys ever want to like give talks here after you like read a cool blog post, you're very welcome to do so.
Thanks, everyone.